Okay, so welcome, and so here's the theorem that allows us to be able to say that a Taylor series converges to a function that it represents. Okay, so here's what we have. So this is called the convergence theorem for convergence for a Taylor series. It says, suppose that f has derivatives of all orders on an interval I containing a, then the Taylor series that represents that function given by this formula converges to the function f of x for all x in the interval I if and only if the limit as n approaches infinity of the remainder r sub n of x equals 0. For all x in the interval I. And so if that is true, then, and again, the if and only if says it goes both ways. So that means if we can show that the remainder, the limit of the remainder goes to 0, then that tells us that this Taylor series converges to the function for all x in the interval I. As long as this is true for all x values of x in the interval I. Okay? And then also, if we show that this Taylor series representation for a function is convergent on the interval I for all x in that interval, then it also tells us that the limit of the remainder must be equal to 0 for all values of x in the interval. Okay, so this is what we call the if and only if means it goes both ways. It's the biconditional. Okay, but we're going to be using it this way. We're going to be looking at this to show that this converges to the function at hand. Okay, have a great day.